My name is Paul Coggin. I'm a cyber subject matter expert at New Systems in Huntsville, Alabama. My role in New Systems, I specialize in telecommunications service provider technologies and cybersecurity, and also have a strong interest in space systems. And so this presentation, we're going to go into some real world examples of what has been happening historically in space, and talk about some theoretical possible cybersecurity issues. And we'll go into some best practices and recommendations for securing space systems. But in the realm of space systems, we're specifically going to focus on the spacecraft for the majority of this talk, specifically satellites. To get started, this is an example of a ground system network. In this case, we're looking at a ground system for NASA, where they have locations around the world so that they have complete coverage of satellites as they orbit the Earth. And you can see that they have, like I mentioned, they have ground systems across all the different hemispheres, from the north and the south of the globe, so that they have complete coverage as the spacecraft are orbiting the Earth. Depending on the size of the constellation, may not have this large of a ground system network. One thing to call out is, as space systems are evolving, this next generation of space systems, a great number of the newer ground systems are actually being deployed in the cloud, just like we're deploying a lot of the enterprise and service provider services in the cloud. So is space ground systems. You have Amazon, Microsoft Azure is also in the ground system business, and Google is getting into the ground system business. I've been reading where SpaceX is working with Google for their new satellite constellation that they're deploying. And there's other cloud vendors that are providing ground system services as well. When we talk about spacecraft orbits, there's a low Earth orbit. You hear about LEO, where you're about 160 to 2,000 kilometers above the Earth. That's most of what's in the news these days. And then we have the high Earth orbit, around 16,000 to 130,000 kilometers. Have the medium Earth orbit, the 2,000 to roughly almost 36,000 kilometers there, close to it. And then GEO, and you'll hear a great deal about GEO in the news as well, where GEO is around the 36,000 kilometers, and where the GEO is more of a fixed configuration, where when a satellite goes up into a GEO orbit, it orbits with the Earth so that it has a fixed location to provide, say, telecommunications, cable services for fixed locations on the Earth. So just wanted to give a brief overview of some orbits. Focus our conversation for this presentation is threats to the space systems. The Federation of American Scientists, they broke it down to around 5 main categories of threats to spacecraft, because we're going to focus on the satellites in this conversation. There's deception, where you're making the targets, the spacecraft, report incorrect information. You have disruption, where we're going to temporarily degrade the capability of the spacecraft. Maybe denial, where the capabilities are being temporarily disabled, where there may be degradation, where a capability is degraded irreparably. Maybe an example of degradation is if someone had on the ground, or possibly in space, attack the satellite, maybe from the ground. You damage optics with some kind of high-powered laser, possibly, so it's totally irreparable. Or some kind of kinetic physical attack could degrade if it didn't just totally destroy. And then again, what's been in the news a whole lot here lately is complete destruction of satellites with anti-satellite weapons, for example, where say a missile hits a satellite and blows the whole thing up. So it's complete destruction, which could also happen with debris. There's a lot of debris in space that could totally cause destruction or cause irreparable degradation, which would not be a cyber attack. It just there's just the threats of the debris. Now, from a cyber threat, some of it's not totally cyber. Like jamming is more of electronic warfare, where you're going to overpower the radio signal with a stronger RF capability. But electronic warfare and cyber are merging together in most conversations these days. So you have jamming, have malware. We're going to go into some examples of where malware are being seen. Spoofing, the control and payload, the control and the TT&C, where your telemetry tracking and command, being able to send commands and control to the satellite, manage where the satellite is, being able to replay. You might be able to replay and hijack connections because the connections may not be encrypted. You might be able to just sit there and passively listen to connections, eavesdropping, if you can lock into the signal and listen. As we mentioned earlier, there are some threats that are reversible and others that are irreversible. So like some actor has the resources to actually jam a satellite's RF signal. They can start jamming, affect the capability of the satellite, the communications, and then when they turn off the jamming, then the vulnerability, the damage would go away. The vulnerability doesn't go away, but the damage would go away. The interruption would go away whenever the radio signal is tape removed. But as you move to the right, if you start coming under some kind of kinetic attack, say a missile or some other kind of space weapon or possibly debris, it's going to be non-reversible. You start getting into the physical damage to the satellite, spacecraft. That's not going to be reversible. It's going to totally damage the spacecraft and take it out possibly, as we've seen with the recent ASAT events in the news. There are a lot of different actors in these that may be looking at space. Just like with an enterprise, you have the nation state, the military, intel agencies, possibly insider threats, somebody, an individual, and depending on the resources, someone might be able to, with minimal resources, be able to passively listen to satellite network traffic, or someone with more resources are going to be able to possibly not have to deal with it, not wait for just open satellite communication, but they might be able to actually hack into a ground system and be able to exploit a ground system, and in turn exploit the trust relationships with the spacecraft and take control of the spacecraft if they have the capabilities and the skills to do that. And we're going to get into some examples where some more sophisticated threat actors are actually able to take control of spacecraft. When I like to talk about attack strategies, looking at going after a system, I like to go and develop an attack tree to better understand how an adversary may want to go after the target. I do a lot of red teaming, penetration testing for different organizations. So I like to go and map out, figure out what the target is going to be and come up with a strategy and represent it in an attack tree. So I got a good understanding of how we may proceed to accomplish our goals. And this is real high level, not totally in absolute detail, but if going after satellite, you might want to go out to the ground station, maybe emulate an insider that has access, or look at someone who has remote access, depending on what kind of remote access is available into that ground system. You would typically, historically, you would think that a satellite ground system would be air gapped, but now we've got the ground systems moving to the cloud where they're accessible over the internet. So So there could be some remote access that could be exploited to get access into a satellite ground system. Theoretically, there is conversations about a satellite to satellite type attack, but right now I have not been able to find anything out in the open source where that has been done by anyone yet, where there's been any kind of cyber attack going from sat to sat. That might be something that we see published in the future, but I have not personally been able to find anything on that yet. It could be someone throws up an unauthorized ground system capability and starts trying to take control of a satellite, and we have some examples of this where that could be happening, where they could try to control a sat from an unauthorized ground system. Speaking of malware, a lot of people have talked about Stuxnet in the past, but one thing that jumped out at me doing research for satellite vulnerabilities and what is going on in the space industry, I ran across that the famous Stuxnet malware is suspected to have actually taken out a satellite called INSAT-4B that was owned by an Indian cable TV satellite network. And so the Stuxnet was somehow able to get into the ground system through the internet. It could have been that someone brought it in through an infected thumb drive or some other medium, or through an infected laptop and brought it in to the ground system, or but somehow it got brought into that network. It wasn't just specified how it got there, but it was able to compromise get into the ground system and find its way on the INSAT-4B, where it is said that INSAT-4B was running the same PLC software, utilizing the same PLC and the same WinCC software to manage it that was targeted by Stuxnet. So Stuxnet ended up disabling the INSAT-4B satellite. So it's one example that is out in the open source where malware has actually disabled a satellite. As I've been studying satellite communications and learning more about space systems, it's fascinating to me how many of the space systems, the satellites, are not using encryption. One would assume that encryption is being used because you would not want anyone to interfere with your satellite communications. Well, it turns out that doing a lot of research, that a great deal of the satellite communications are not encrypted. It's recommended to be encrypted, that you use encryption just like internet traffic, if you want privacy, to encrypt it, but a lot of the satellite traffic is not encrypted, and there's a lot of tools and capabilities available to eavesdrop and to listen to the unencrypted traffic. And the reason that the traffic is not always encrypted is because of the cost of hardening the satellites against radiation. There's a lot of space weather, radiation coming from the sun, solar flares, et cetera, that can disrupt communications with a satellite. And then that radiation that space weather up in the upper atmosphere can not only interrupt communications, but it can also affect electronics, and over time degrade the system itself, the different electronic components. And if there was to be some kind of like a solar flare storm or what have you, and you're having encrypted communications, it could interrupt the encryption keying so that you would lose your communications with a satellite. So it's easier to have communications with a satellite when you don't have the hardening, radiation hardening, to just not use encryption. Because if you're going to use the encryption, you're going to have to make sure you have really good radiation hardening on that satellite to make sure that you can maintain your communications with it. And so that's why we don't see 100% encryption everywhere, because it's going to drive up the cost. But that also makes the spacecraft inherit the vulnerability, and then your communications to be open to the world to possibly listen to if they have the right equipment. Another example of unencrypted satellite communications being intercepted is down in Brazil. Apparently, there was a large number of people that were aware that the U.S. Navy was using open satellite communications in the UHF bands. And at one point, they arrested 39 people across 6 Brazilian states for illegal utilization of the Navy's satellites. Now, and my understanding is, reading the research, is shortly after they arrested that group of people, others started back using those satellites again because they were open, unencrypted communications. It was available, so they used it. Another example of unencrypted satellite communications being utilized was the Turla malware, where the command control of the network would use both the landline, and it would use the satellite to do its command control, and it could broadcast down from the satellite and hit systems that had been exploited, and be able to communicate with them through the satellite. And you could not see the synchronous connection. It was async. So part of the connection went over a landline, and part of the communication went over broadcast satellite down to the earth. So it made it really difficult to catch. Very sophisticated malware to be able to do that. And that was the Turla attack. And it was also another example. There was back in the Iraq War, apparently some people figured out that the UAVs, UASs and stuff, some of the space aircraft were not using encryption, and they were able to capture communications because they were open, unencrypted, using off-the-shelf commercially available software to be able to go and decode satellite communications. I mentioned this earlier. This is an example of a theoretical attack against satellite, where you would have a couple satellites up in space that are communication satellites that are sending comms between each other, and an adversary is able to push up another satellite, a third satellite, for example, and be able to do a man-in-the-middle type attack and intercept communications between satellites by being able to get in close orbit. Maybe be able to do a different kind of cyber attacks if they're not using strong encryption, just like they would on the ground. Now, more and more of the communications in the long term are going to move to optical, free space optics, and that's going to be harder to do a man-in-the-middle type attack when you start talking about optics, because it's going to be very directed, and it's lasers. So it'll be interesting to see how that evolves over time. A real-world attack against a satellite that's documented in open source. One of the first ones that I read about was the ROSAT satellite. Back in 1998, it was a German-U.S. satellite, and used for looking into space. And apparently, it looks like the ground system was attacked, and through the ground system, the satellite was able to be taken control of, and the solar panels was able to be turned so that it was damaged, and so it was no longer usable. And attribution was pointed back to the Russians in the ROSAT attack. And then there's the Landsat 7 satellite attack. It happened in October 2007. And it happened twice, and it also happened a second time in 2008, where it was taken control of for like 12 minutes. So it's another example of a satellite that has been hacked and taken control of. And then the Terra satellite experienced 2 minutes of interference in June 2008, and then later in October, it experienced 9 minutes of being out of control and someone else having control of the satellite. So that's another direct attack on a satellite spacecraft. Very similar to that, we have the NOAA weather satellites. And it is speculated, the attribution in the open source says that the Chinese hacked this weather system satellite and was able to take control of it for a period of time. And another satellite that got taken, that I was surprised to hear this story about, there was the UK Skynet satellite. Apparently Skynet is comprised of 4 military satellites that the UK uses. And in this scenario with Skynet, an adversary was able to capture one of the 4 satellites. It's a 4 satellite constellation, from what I understand. And one of the satellites was taken control of and was held for ransom for a period. Then there's other examples of cyber activities in space, where on the space station, apparently it's very common knowledge, not in the control system of the space station, but in the where other network functions are happening, system functions, it is common for there to be a malware infection, apparently, with thumb drives, that the astronauts are bringing thumb drives and they're bringing laptops that have infections that are infected and introducing malware into the space station network. Now, there's nothing saying that anything has been infected into the flight control system of the space station, but just in the networks where the astronauts are plugging in laptops, et cetera. There's been a few cases where malware has been brought onto the space station. There are some good reference standards for securing the spacecraft, both of the ground systems and the spacecraft themselves. The Consultative Committee for Space Data Systems, they write the standards. They're kind of like the IEEE, ITU, for writing standards for network protocols, the communication standards, how systems should work together and integrate. And they also have a great deal of documentation and specifications for how these systems should be secured, how the protocols should be secured, how cryptography should be implemented, how the various protocols should be secured. The ground systems and the spacecraft architecture should be developed to ensure security. So there's good engineering best practices out there for space systems engineers to use as a reference to design these systems that international organizations all collaborate on to develop, to make sure that there's some good methodologies to be used. Some other best practices that are out there for securing space systems. Matter has published some best practices. MIT Lincoln Labs has published documentation on best practices for securing small satellites. NIST is currently working on a standard for commercial satellites. I believe it's called NIST 8270 is the document that NIST is working on. And then there's the Committee for National Security Systems, some U.S. government organizations, the CNSS. They have a number of documents out there for best practices for securing space systems. In the Aerospace Corporation, very similar to Matter and MIT, the FRDCs in the U.S., they have best practices for securing space systems, both architecture and policies. And more recently, there's the Orbital Security Alliance, and they have recommended best practices for securing satellites that are available for reference. Some things that you might want to think about when you're starting to work on designing and building your own spacecraft is to use the DevSecOps and design security into the satellite from the very beginning, both hardware and software. Make sure that it's hardened, that you have the radiation hardening so that you can protect the system from the hostile space weather environment, from the solar radiation. Looking at the supply chain, the different operating systems, the real-time operating systems you might be using, that whole chain of custody is secure, and that the applications, et cetera, are all been that you understand where all your components and software is coming from. Look at implementing the zero trust model with defense in depth, to look at all the different trust relationships and the interdependencies in both the ground system and the spacecraft. Make sure everything is secure and locked down. And encryption is being used. And more, the spacecraft that are being deployed, the next generation spacecraft that are coming online, are going to have the ability to support virtual machines and containers. So it's going to open up the capability for doing logging and increase the ability, the resources to do things like intrusion prevention systems. And we can look at applying machine learning and artificial intelligence and monitor the commands that are being sent to the spacecraft to make sure no one's trying to help us manage that spacecraft, and we're only getting the type of commands that we expect in the order we expect them. That there's not some unauthorized configuration commands being sent to the system, or operations trying to manipulate the payloads. And we need to closely monitor the telemetry tracking and control of the satellite. And also with a lot of the satellites are being deployed now, where they even have like a lot of them are like running Linux and are being constantly patched to add new features and new capabilities to support the control of the spacecraft and the payloads. But we need to have really strict system configuration management to make sure that that constellation, we know all the different patches and configuration status of these systems, so we know where we're at and make sure nobody's helping us manage and mess with the configuration of these systems, as we've shown in other slides, which are not only theoretical but very possible for someone to get unauthorized access to and help us manage our spacecraft. That is the overview of spacecraft system hacking that I wanted to share with everyone today. I really appreciate the NANOG team giving me an opportunity to come and present it at the conference. And at this time, if there's any questions, I'd be happy to answer questions. Thank you.
Thank you, Paul. We do have a few questions for you. Take the first question on the chat. Coming to us from Robert, Carolina. Question is, I take your points about attacks that jeopardize the operation of the SAT itself, and you make a good case for encrypting command and control signals. If people who use space segment encrypt their traffic end to end, does this mean that the threat is effectively limited to SAT operators rather than the end users?
Well, what I've seen is both there's a lot of examples that's been published at DEF CON, Black Hat type conferences where end user traffic has been recorded, where it's out there passively open so that someone can see whatever communications you're having as an end user. It's out there in the clear to be sniffed, just like you're sniffing it off of a wired network. You can capture, if you got the right equipment, you can capture anyone's satellite traffic. So if you have traffic that is sensitive in nature, say maybe it's some kind of industrial control system, SCADA type traffic that you're utilizing a lot, that would certainly be of concern. Or if you had sensitive information like passwords or that pass in the clear, that someone can sniff off the wire. So yeah, it could affect end users as well as the sat to ground system.
Thanks. Next question is from Jorge Amodio. What are your thoughts about DTN and BPv7 BPSat?
I have not read up on this.
All right. Well, that's all the questions we have. Thank you again for your presentation and time today, Paul.
Sure. Thank you.